So on y-axis, it says, a graph is said to be symmetric with respect to the y-axis if for every point x, y on the graph you have his mate is the opposite x, same y. So here you would notice there is x, y, there is the opposite of it, same y value, so now you're moving strictly horizontal. Here's my coordinate point. Now you notice that it's going to be horizontal directly across. It will keep the same y value, but the x values will change. So if I have 3, 2, what is the coordinate point which is symmetric to across the y-axis to 3, 2? It's going to be negative 3, 2. So that says I'm going to go here, and then I'm going to go additional 3 units. Y stays the same. X changes. So what I'm looking at is if this is 3, 2, symmetric with respect to the y-axis is negative 3, 2. Y stays, X changes. It's very visual. So in general, and this is the picture I draw all the time, I have a point xy. If I want y-axis, this is going to go over essentially minus x units, and it's going to be the opposite of x, same y. So that says, so in general, if xy is on the graph, so is the opposite of x, y. So we want to draw a graph which is symmetric, in other words, so that this would fold over across the y-axis. So if I know, here's my, it's not a function anymore. Why would I just say, I just said something. Why is this not a function?
Vertical line.
It fails a vertical line test. It's not one-to-one. So I can't say, well, that's f of x. Well, it isn't because it's not a function. And my coordinate points are 0, 4, 2, 2, 0, 0. So if I'm going to deal with symmetric, I'm changing who?
X.
The x. So it's 0, 4, negative 2, 2, 0, 0. So 0, 0, negative 2, positive 2, 0, 4, and there is his other half. Well, it's not a very good other half, but it's the best I can do. Not a real good-looking circle. Circles are symmetric. They're handy little devils. I like circles. Except if I'm going around in circles, and that's not good.